Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop your private Stack Overflow. Yes, we are going to develop this application that you can currently see on your screen, your private Stack Overflow that will help you perform generative search on your code bases. Now earlier we have seen that how we can retrieve information from documents, CSVs, images, videos, etc. different data formats. But what if we have to retrieve or perform searches on your code bases? Now why this is important is because you are working for an enterprise or some companies and you guys have your proprietary code bases, 20, 30, 50 years of code bases of different projects. How you can create embeddings out of those projects or the code bases, and then you can perform some kind of search. So when a new developer or when a young developer comes in the team, how he or she can perform some search to understand or to increase the efficiency, okay, at the workplace. And that's the reason we are going to do that. This entire application is built on the open source stack. We are going to use a large language model by Stability AI. We are going to use that model Stablecode, and for embeddings as well, we are going to use a model from Microsoft, Unixocoder base. Microsoft has CodeBert, Unixocoder base, Graph Coder, etc., etc. So we are going to rely completely open source. We'll run it on a CPU with a good, with decent enough latency as well. I'm going to build a FastAPI backend, so you can also use an API as well as a microservice or something like that. If you want to use it, go ahead, deploy it, and you can deploy it on some cloud or something just to use that API later on. And I'll also show you that how we can use Jinja 2 templates in FastAPI to build this quickly. So you can see currently I am on your private Stack Overflow. Enter your question. I'm just going to paste my question. How do we define HF argument parts? And I can ask, hey, why did you select this question? Now the reason is because I have taken 3 files from Hugging Face's Transformers GitHub repository. A huge credit to Transformers. Without Transformer, you would not have seen this rise in generative AI ecosystem. So I have taken these 3 files: run audio classification, run image classification, and run question answering.py. And what I have done, if I show you here on the home, okay, let me just go to desktop, and in desktop, my project, coding assets, data, I have these 3 files that you see: run audio.txt, run image.txt, and run qa.txt. Now I have downloaded all these files from GitHub repository. You can take any GitHub repository, more than 80 programming languages. It performs well. And I have taken this run image classification.py and all the other 2 files, and then I just change the extension from py to txt because I'm going to use Langchain data preprocessor modules to perform some pre-processing steps. Now if I ask this question, how do we define HF argument parser, and I click on submit, what it does, it takes around 30 to 40 seconds depending on what kind of machine you have, but it's faster enough, okay. And how does it work? First we create the embeddings, the vectors. We have to put it in a latent space, and we are utilizing this feature extraction model, which is very domain specific. Now you would have this question in your mind that why are we not using sentence transformers, for example MPNet or MiniLM version 2? Why are we not using those models from sentence transformers? Because those works really good on text and sometimes on images, but you have to rely on domain specific model. For example, if you are dealing with the code bases, for code bases you might have to look at the models which are really good to extract features from code bases. Like we have models like CodeBert, CodeGX, Unixocoder, Graph Code, etc. Right? So you have to look at these models to extract the embeddings or create the embeddings and then save it in a vector store, in-memory vector store. We are going to use Faiss CPU here in this video, but you can use any other vector store or vector database you want. Now we're relying on Microsoft Unixocoder base available on Hugging Face. That was a great rhyming. Unixocoder base available on Hugging Face. And as a large language model, we are going to use Stablecode instruct model. It's an instruction based model, and we're going to use this model by Stability AI. It performs really good, to be honest, on multiple questions that I have asked or I've searched for. Good enough large language model, and 3B, and they have some licenses. We are not going to use the exact same model. Again, we have to rely on the blocks creativity of effort, whatever you say it, we're gonna use a ggml variant of this model. I'll give you the link in the description and how you can download that model when I'm writing the code. Okay, if you see it over here, okay, so we have this def hf argument parser. This function returns the input, output, and target as numpy arrays. I asked a question, or I basically search for something in my knowledge base, the code base. How do we define hf argument parser? And I got the code, and this is what I'm going to develop in this video, guys. The UI might look little messy, but I'm not a web guy, okay? I'm not a web technology expert, okay? I'm an average guy on those things, but you can see we have your code area and also giving the source document, from which document this information has been retrieved or this code has been retrieved. That's what we are also doing it over here in the right hand side in the source document. You can find it out all about your whatever question that you have searched for. Okay, you can find it over here. And so this is what we are going to build, guys, in this video, and this is going to be a very exciting video, to be honest. And you are feel free to use any other large language model. You can use llama 2 as well, the ggml variant of llama 2. That might perform good as well. Maybe you can use star chat, star coder, or wizard coder as well, because those are very code specific models. Now you can get your code here, def hf argument parser. This function returns the input, blah blah blah, parse each example in the data sets, input output targets, and then return the numpy array as well over here. Fantastic. So this is what we are going to build. So without any further delay, guys, now I'm very excited, so let's build this application. Okay, so to build this application, now let's first see that what are the things that we need and how the high level architecture will look like. So we need, let me just call this Private Stack Overflow. Okay, this is what I want to name this. And the first thing that we need is, of course, data, and the data will be nothing but some code files. Okay, this will be some code files that we will take it from GitHub. So I already have downloaded it. I'll just, so you can take any other code bases you want. Okay, and this will be available on the GitHub repository as well. Now you need data, the code files, and once you have data, we need a framework. And we're gonna use Langchain here, which is a framework basically to build LLM application faster. Okay, and for that we're gonna use its prompt. We're going to use prompt template because we have to engineer the prompt a bit, and then we need its data loader and preprocessor basically. So let me just call it preprocessor, and then we need some chains. So one of the chain that we need is in this video we're going to use retrieval QA. So this is on framework, and then we need an embedding model to extract feature out of those code bases, an embedding model, and for this we are relying on Unixocoder. So you can see this library over here, or the model over here, sorry, excuse me, Unixocoder base. The library is Hugging Face, by the way. Unixocoder base. This is what we are using. Microsoft, it's by Microsoft, and Microsoft has a lot of other models as well. When it comes to code related problems, they have CodeBird, they have graph related models as well that you can check it out. Now after embedding model, we need an LLM, and in this video we're gonna use, you can see it also has been opened here, Stablecode, the instruction model, Stablecode instruct, and Alpha 3B. This is the model that I'm going to use in this video. Okay, and these are the things that we need, and we need like for backend we're going to use FastAPI, one of the most underrated library or the framework that has been ever built for Python. FastAPI we're going to use for backend, and we'll build a simple kind of an API, and also we'll use Jinja 2 here. So I'm not going to write any code in for the front end. That basically a simple UI. I'll give that it's built on basically. Let me just write for front end as well, because if you are seeing this and you want to extend this further, it has been built using Bootstrap 5.3, the latest Bootstrap version. I think it's more than 5.3 also. They have 5.4 if I'm not wrong, but this is based on Bootstrap 5.3. Okay, so these are the things that we need. Okay, and you have your code. Now you have your code file. You basically chunk this out. So first you load this using Langchain, and once it's loaded in the system, so for example, suppose this is loaded, you create chunks of this. So basically we chunk this through some, after splitting it out, and then you're passing to an embedding model. So that will pass through an embedding model. So this is passed through an embedding model. So let me just write an embedding model here, and then we save it in a vector data store here. We are saving it in a vector store. Whatever you design it, I don't know. So we are using Faiss CPU, which is by Facebook. You can use ChromaDB or Qdrant or Milvus, etc. Whatever you want to use. You can use Pinecone as well. But I am a huge advocate of open source, guys, and I don't want to pay money to build applications, to be honest. Okay, and then we have Faiss CPU, and okay, let me just do this. This is done. So this is the first step that we are gonna do here. Okay, now once user query is, so when user asks for a query, so there is a query, for example, okay, like HF argument parser or something. This is again passed through the same embedding model, and we get the relevant chunk out of it. So you get the relevant chunk here, and this comes from basically this Faiss, the vector store that we have, okay, here in the relevant chunk. And then we use Langchain chains, etc. here that takes care of your prompt, etc. And then give it to an LLM to retrieve the information, okay, or to perform the search. So that's what we are going to do here, guys. Very high level. So I'm not creating this architecture in detail because there are a lot of videos that I have created recently where I have explained this in most of the videos. Please watch couple of other videos where you will see this architecture on very high level. But this is now, I assume that you would have seen a lot of videos on information retrieval task, and this kind of works same way. There's a lot of application has been built on GitHub, Doc GPT, Document GPT. Even Siraz has built an application the other day, Dr. GPT or something. So there are a lot of development is happening, right? So anyway, okay, now jump in, guys. So yeah, that's the data that we need. So I have downloaded 4 files, all of these Python file. You can see AOAI by .py, which is by Microsoft. They have open source something. I don't know what are the things that they have open source. I was reading it on LinkedIn that they have open source their UI or code bases or something. Okay, so that's the code to interact with Azure OpenAI, set it up on their private VPC or something. I have downloaded that file from GitHub. Then I have Karpethis Meta Llama, which is from Llama CPP. So I have taken that file from his GitHub repository, and a huge fan, and I have a lot of respect for Andres Karpathy. And then I have a graph operation.java, which is graph operation, which is from TensorFlow GitHub repository, for the Java. And then we have this by Transformers repository, run image classification. Now what I'm going to do here, I'm going to rename the extension from py to txt for all of these files, because I'm going to load that through a directory, and I'm going to use text loader for that. But you can also, anyway, if you don't want to use Langchain, you want to write your own pre-processing function, and I will recommend that if you are doing something in production, to write your own pre-processing function where you'll have more control and customization options that Langchain might not provide. But just to keep it simple, I'm just going to rename this. Okay, you can also in end you can load it in a list or something like that separately as well. Now this becomes my data source, and if I come in the root directory, this is the model that you need. Stablecode instruct alpha 3 billion ggml version 1 quantized 5.1.bin. I will give the link of this model in this description, the video description. You can ignore this file. The reason I have kept this file, if something goes wrong with the Hugging Face embedding module, I can utilize this default Python file, official Python file on Unixocoder. And the reason I'm also talking about this nowadays, because in production you have to be really careful when you are building GenAI applications. You have to put your own guardrails or something, right? So it's better to write custom functions for validation, pre-processing, prompt blocker, etc., etc. Okay, let me just open this in code here, and I'm going to open this in code and to code. Okay, and then let me activate my Langchain environment where I have installed all the required dependencies for this video. Okay, and I'll upload that requirements in the GitHub repository. Okay, let's write the code. The first thing that I'm going to do is I'm going to use my ingest.py. Okay, that's what we're going to need. If I show you here, you can see that this is what we need: embedding model, Unixocoder base. And if I just go a little up, you will see the first thing that we have to do. We have to load the file and then perform some pre-processing steps before creating the embeddings and save it in a vector store in this for this use case. Okay, now let's do that. So the first thing that we have to import few libraries, and of course we have to start with Langchain thingy here. So from Langchain.embeddings, or let's do step by step. So document loader. The first thing is document loader from Langchain.document loader, and I'm gonna import its loaders, by the way. Import text loader. Excuse me, text loader. I'm also going to import directory loader. Okay, so this will help us load the file from a directory, and the reason I have text loader because it's a text file. If you have PDF, you have to do PyPDF or PDF or something like that. Okay, depends. I think it supports around 14 different type of data formats in Langchain. Correct me if I'm wrong, maybe they have increased by now. Okay, and the next thing is from Langchain we need some splitter, guys, right? So let's do text splitter. We have to split that text splitter. This is what I need, or to make it more efficient, let's do recursive character text splitter. Recursive, I hope I spelled it right. Recursive character, where is tab 9 when we need it? Okay, recursive character text splitter. Excuse me, recursive character text splitter. Okay, this is fine. Now text splitter, then what we need is embedding thingy here. So from Langchain.embeddings, and for that I'm going to use Hugging Face embedding module. So Hugging Face embeddings, and in that you can pass most of the embeddings model which is available on Hugging Face. Make sure that is supported by Langchain. Okay, now from Langchain.embeddings import Hugging Face embeddings. Now we have created the embeddings. Now we need a library that will help us, not library, the module or class, whatever you call it, to save that vector store, okay, in a vector store. Now for that we're going to need from Langchain.vector stores import. I'm going to use Faiss here. That's it. I'm using Faiss CPU. You can also use Faiss GPU if you have GPU. Okay, that's fine. We have directory loader text, etc. This is what we need. So let's now we have a data path. So let's call a data path, which is, and the same terminology is available on my other videos as well. So data path is nothing but which is data, and let's define a db Faiss path, the path that we want Faiss to create it automatically. So db Faiss path, and for that let's call it something like that I always use: vector store, and then db underscore Faiss, If you are using ChromaDB, make sure that they have migrated from DuckDB to SQLite. So if you are getting any error, probably you have to look at that nowadays. Now let's call it create vector database or something here, vector db, and let's call it create underscore vector db, vector db. And in this, the first thing that we're going to do, have a loader as usual. So loader, and I'm going to have directory loader, and in this directory loader I'm going to do few things, and that's why I'm writing the code. Otherwise I can also take it from my GitHub repository. I will take few of the code snippets, but here the first thing is data. Okay, let's have a data path which is data. Now once you have the data path, you have to give a loader class. Okay, and that's why we have to give this loader class here. So if you have a PDF, you will probably give PyPDF or something loader, or something like that, PDF loader. But I have a text, so I'm gonna use text loader. Okay, and I'm going to use few other arguments as well. Within this, I'm going to do, okay, recursive equals to true, and let's keep progress equals to true as well and see if that makes any sense. Excuse me. So progress equals to true, and then I also want to use multi-threading because it's really helpful when you want to create embeddings for multiple files. Multi-threading, let me come a little closer, I cannot see it. So use multi-threading, and of course I want to do it true. And then I also need maximum concurrency, so let's put some values for max concurrency. Concurrency, I don't know why I'm not getting that suggestion here, but I hope it's correct what I'm doing. For now, let's keep it 8. Now max concurrency, use multi-threading, true, so progress, this makes sense. Now let's call it raw underscore documents, and those raw documents I'm gonna call it loaded.load. Just going to load that, guys. Okay, with load module here, loaded.load, and text splitter. So text splitter equals text splitter dot not text splitter, recursive character text splitter. Okay, recursive, yes, character text splitter, and in this recursive character text splitter we're gonna pass our chunk size. So chunk underscore size, and I'm going to keep, let's keep 500. And guys, if to be honest, see, I'm not building a product here, to be honest, and you have to play around this. Please keep higher chunk size and also the chunk overlap, and you can play around it to see if that makes any performance improvement. I do believe I have seen it when we are building POCs and solutions. We have to be very careful when we select a chunk size and chunk overlap, depending on what kind of data that you are dealing with. But just to keep it simple, I'm going to keep chunk size at 500. Maybe you can also try with 1000 or something. And then for chunk overlap, and let's keep 50. Keep it small for now to create this faster. The embeddings, etc. Chunk size, chunk overlap. Now we have a text splitter. Now the next thing is we have to get the text out of it. So text splitter dot split documents, split underscore documents, and here we go, split under document, that's pass raw document. That's it. Now we are okay with, so this contains all of your text, splitted text. And the next thing is I'm going to have an embeddings variable where I'm going to call Hugging Face embeddings, and in this my first thing is model underscore name, which is going to be your Microsoft model. So I hope it's Microsoft. Let me just copy it. Very simple, guys. What you have to do, you have to come over here, just copy this entire thing, and let me just remove Microsoft and paste it. So simple, right? Not rocket science. My model name. And once model name is done, then we can also set some squawks. So the first thing, okay, let's have it's a dictionary. So you can see it says dict. So it's a key value pair. Okay, so let's me define a key, which is going to be device, and my device is nothing but a CPU machine. If you want to use CUDA, you can also do that. Okay, make sure you have a good enough VRAM to deal with it. Device and CPU. Okay, fine. And then here we go. So DB, which is a short form of database, Faiss dot from documents, from underscore documents, hope I have spelled it right, documents, and our edge text, and then pass embeddings. That's it. Now let's save it locally. So I am writing this ingest.py because I wanted to show you a couple of things in the loader and the embeddings. But when I'm writing the code for app.py, I'm going to copy a lot of code snippet from my GitHub repository because it's very duplicated, right? So db.save local, and in this I'm just going to use db fast path. Okay, and now let's also run this. So if name main create vector dev, the function name. That's it. Okay, so we have written this, and what we are doing here, guys, you have to set a data path where you have your data files. You can see AOAI text to run image classification. We have 4 files. And then we have a loader, directory loader class. We are loading it with some arguments, then raw document loader.load using recursive character text splitter, have some chunk size and overlap, then splitting it out using an embedding model, creating the embeddings and saving it in a vector store. That's it. So let's run it. Okay, and you are doing it everything locally. We are not using any online service or something like that. Okay, so now let's run this, guys. And it says got an class. I don't know where is class. It's CLS. Sorry, that was in little bit in excitement. Okay, loader CLS, and now let's do Python ingest.py. And you can see we are 100% with this 4 files, creating some sizes. You can see no sentence is fine. Okay, I don't have, it says GPU quantization are unavailable due to bits and bytes, etc. I'm okay with it. Okay, I don't need those things. And what it will do, you can see the left hand side in this coding assets directory, you will see a new folder called, what is the folder name that we have given, vector store, and within that we'll have something called db_Faiss. And that's what you can see now. We have created this automatically, and so it has been successful. And you can see we have two files, index.fast and index.pk, or the serialized files. Okay, now let me go inside this vector store. You can see we have two items, and you can see the good enough size of index.fast and index.pkl. Okay, you can put n number of code files, thousands of PDF files. Okay, PDFs, TXTs, and some JSON, etc. You can do that. And let me just come over here. Okay, so now we have written this, guys. We are okay with our ingest. Now we're going to write our app.py. We have created embedding, so that part is done. Now we're going to write an app.py where you'll use this model, guys. Okay, so now let me do that, and I'll also download. I'll put my index.html static and templates file into it. So now let's perform that task. So let's create an app.py here. So I'm going to create an app.py, and all of our app logic will go inside this. Okay, so for that we're going to import few things. Let's quickly import it. The first thing is an LLM, and we're going to use something called C transformers. So C transformers is a Python binding, for all of this LLM, or the transformers model. I will say the transformers model, a model which are based on some transformers. It's a Python binding for the C++. Okay, and it helps you load this model and inference it. At least it takes less load, and it's really helpful. So we have Llama CPPP, we have Cobalt CPPP, we have a lot of other way we use this large language models on a commodity hardware using GGML or GPTQ model. And that's why we are leveraging something called C transformers, which is by Marella. So credits to her, her or him, I don't know, sorry, so if the gender, but credit to whoever has created, right? So from Langchain.llms import C transformers, and then we need Langchain.chains. So we're going to use some chains. I'm going to use import retrieval QA. Retrieval QA, I hope this is how we spell it. And then I also need LLM. Let's keep LLM chain for as well if we need something like that. From Langchain import prompt template, import prompt template. This is fine. And I need, let's keep OS now if we need it, import OS. And then need JSON for FastAPI. So let me just also use that. I need from embeddings also, Hugging Face embeddings, right? Hugging Face embeddings, and then Faiss as a vector store. So from Langchain.vector stores import Faiss. Okay, then I need some FastAPI dependencies, guys. FastAPI we are going to use as a backend framework here, to write our Python backend code. So from FastAPI you can also use Django or Flask if you want to Streamlit as well, Gradio, etc. Now from FastAPI import FastAPI. I need form, I need request, and I need the response. And what else I need? I need file, I need also depends, I need HTTP exception for handling error, etc. and I need status. Okay, that's what I need. And then I need from FastAPI import, or not FastAPI, let's do it from responses as a redirect response for localhost 8000. So from FastAPI responses import redirect responses. And then I also need from FastAPI.templating, I need Jinja templating. That's gonna use index.html templating, Jinja 2 templates, and I need static files. So from FastAPI, so whatever files that we're gonna create embeddings, etc. We are going to show that file right on the UI, and that's we're going to save it in a static file. Excuse me. So from FastAPI.static files, you're gonna use import static files. So let's import. And you also need JSONable encoder, okay, to get that JSON, the beautifying or something like that. Okay, so from FastAPI encoders import how do we import that? I think it's in lowercase. Yes, just enable encoder. What else we need? We need evcon also. Okay, so let's import evcon as a server to run this backend. Okay, and okay, let's have dict as well. Import dict. That's what we need. And how do we define a FastAPI, guys? So we define like this, a FastAPI app, and this is how we define. So app FastAPI, I'm gonna mount that as well. So app.mount. The first thing that we have to do, we have to mount our static folder. So let me just call it static, and then I'm gonna use static files within that directory, and my directory is nothing but called static, and then I'm going to use name as static. Okay, so now we have mounted this. Now let's write a template. So templates, and templates is nothing but Jinja2 templates and directory. So just give the directory there, and if you have some other names in your directory, you have to probably give that name, not templates. Okay, now we need few things. Okay, the first thing that we again need that db fast path. So let me just copy this here, db fast path, and then we have to copy few of the few of the code snippet from our GitHub repository. So let's just go and do that. So let me just go on AI anytime. Excuse me, just give me a moment. Okay, AI anytime, and here what I'm going to do, I'm going to use let's use any one of this. So I'm going to use llama 2 medical chatbot code. I'm going to use on model pi, and I don't want to write the same thing again and again. So I will explain that what the piece of code is doing here. So the first thing that we are doing is we are having something called custom, I don't know if I don't copy it correctly, helpful answer. I will just remove this. Okay, now what we are doing here, guys, that we are writing some simple prompt, and we say, okay, look at the context that will come from your relevant chunks from that embeddings, and then the question that end user is going to search. Okay, so we have that context and question, and we are saying use the following pieces of information to answer the user's question. And if you don't know the answer, just say that you don't know. Don't try to make up an answer, only return the helpful below or something. Now let's use Langchain prompt template module. So I'm going to take this piece of code here. You can see set custom prompt, and I'm just going to use that. Come over here, paste it, and here what we are doing, we are creating a function called set custom prompt. When we say prompt template for QA retrieval for each vector store. So we use this prompt template that we have also imported here on line number 3, and within that we are passing our template, which is we have defined on line number 24, that you see custom prompt template. We are defining it, and we are giving an input variables which is context and question that we have defined in line number 27 and line number 28. Make sure that you are giving that which is in the curly braces, not the labels. Okay, and that's what we are doing, and then we are returning the prompt. This is one function that I also need this function. I can also write that code, but I'm just going to use that. So let's also use this function, guys, load LLM. Okay, so let me just also import this function. And what we are doing here, we have a function called load_LLM, where we are using C transformers, and we are using a llama 2. We are not using llama 2 model, but you can use a llama 2 model. I will recommend trying this with llama 2 to get even better accuracy. I don't know, you have to check it out. Let me just give this Stablecode. It should suggest me in bit. Okay, Stablecode instruct alpha and something like that. Okay, 3b. I don't know why it's not suggesting me, but now it suggests when you give dot. That's fantastic. Okay, so here in the model type, you don't have to write a model type of llama, which is this model, stability AI model that we are using. It is not a llama type of model, it's a GPT Neo X model. So what I'm going to do, I'm going to say, okay, GPT underscore Neo X. That's the model you're going to use. Okay, here, model type. And then we have max new tokens, which is 512. And let me just set a temperature to, for example, 0.1 or something. Okay, that's what I'm going to do here. So I just said, okay, temperature is equal to, or let's call it 0, because it's a generative search. We are just retrieving the information. We don't want it to be more creative and, generate a lot of random sentences or something like that. Okay, we don't want it, but you can play around these parameters, inference parameters. Okay, now we're just returning this LLM. Okay, now this function is done as well. Now let's take this function. which is your retrieval QA chain function. So I'm just going to copy this retrieval QA chain and I'm just going to paste this. Now what we are doing here, we have a retrieval QA chain function which utilizes your LLM, your prompt and DB as 3 input params. LLM equals LLM, chain type, which is stuff, retriever, return source document. We also need a source document returning the metadata, etc. And looking at prompt and DB as retriever. That's what we are doing here, guys, with this function. So now let me just do one thing. You can see I'm taking it from here. You would have probably seen this code as well if you have seen my Llama 2 medical bot video. Okay, so let's now use the QA model function, the question answering model function. So I'm just going to come here and paste it. So let me just do QA. Let me just come a little closer. QA bot. Excuse me. Let me just bring it. Okay. Now the def QA bot. Now this is fine. Now the last function that we need is we can also take this final result where we are calling all these functions and getting the response. Like we're writing a large function which is final result. You can see we are calling this QA bot and we are passing the output. We only need the response there. QA result query. Okay, now what we are doing here, guys, in this QA bot function, we have an embedding and you can see it's sentence transformer. So we don't need the exact same thing. So let me just go to ingest.py and we're going to use this embeddings here that we have defined. So let me just copy this embedding model and let me just remove this embedding here. So I'm just going to remove this and paste it over here. So now this holds our embeddings and we are passing it over here, and this local db fast path, you can see that at that place we used fast.save local and here we are doing fast.load local. So we are loading that vector store, in memory vector store for each of the vector, from above function that we have written, and we are looking at in that folder or the vector store, and we are passing that embeddings that user is going to search. And then DB has been called, LLM has been called, QA prompt, and pretty much DB, LLM. Okay, now this looks nice. So now what I'm going to do here is I'm going to write my FastAPI function, the endpoints. So let's write that API endpoint. The first thing that I'm going to do, I'm going to say, okay, app.get, and this is for your template response index.html. So let's do that. So when you hit localhost 8000, you should see that index.html UI. Okay, let me show you. So where that I will just copy it. So you have to, I already have these two folders, static and templates. I'm just going to cut this, come on home, desktop, my project and coding assets, and I'm going to paste it. Now once I paste it, I will show you what I'm talking. So in static I have nothing, but in templates I have a file called index.html, and you can see it's a simple index.html file with little bit of CSS. I'm using Bootstrap 5.3. It has a container and we are using a background, as a dark background, and I have a col sm12. I have some within that row I have some columns, and then private StackOverflow, your name, then we have a form. So this is an HTML file. I'm not explaining HTML, and you can go through it and you can completely modify this, connect with database or something, right, if you want. Let me just do one thing. Let me click on open with live server. Now when I click on open with live server, you can see it opens. The UI is this, your private Stack Overflow. But if you do right now anything, it will not do anything because we are not hitting that endpoint. Okay, so this is an UI. So now let's come back in the code and start writing the code, guys. Now in app.get, I'm not gonna give any endpoint here because this is going to be my landing page. So app.get, I'm gonna use a asynchronous function. That's why FastAPI is so powerful. And async def index, I'm gonna have a request. Excuse me, that's request or request colon, and then you give request. Perfect. Request colon request, and let's write in a beautified way or something like that. Okay, async def index. Now what we're going to return here is just a template. So return templates dot template response. I'm going to use this template response and I'm just going to pass that index.html. So let's pass that index.html, and it's a key value pair. Again, your request and then becomes request. Fantastic. We are okay with this now, guys. We have now async def index, something like this, async def. Okay, now fine. Now the next thing that we have to do, we have to write a post request. So let's do that post request, and that will be our final function. So let's just write that code for the endpoint. I'm gonna make a post request, and my post request is nothing but, let's call it get underscore response. So get underscore response, and in that, excuse me, it's not a function, app.post get response, async def get response, request, and then I'm going to have a query which is going to be a string. So my query is a string, so let's do that. So query str, and in that str I'm going to have a form. So form, let me see, form, and okay, so this looks okay. I have to close that. I'm not closing it, and then that's it. Async def get response, and then become response equals, I'm going to use that final result function that we have defined at line number 76, final result, and I'm going to pass that query that end user is going to search. Okay, so response final result query, and I'm going to write result equals resp, and only need the result. So let's do that result, and now let's also print that in terminal to see if we get any error, we can track it. Okay, so print result. Okay, now this print result is done. So now what we can do for I in response, so resp, we are doing this for source document, guys. So let me just think resp, and I think it's source underscore documents. So let me just do that, and I only need the first document. Okay, and maybe you have to look at the workaround. So right now I think k equals to 2, right? So it, okay, so right now let's only return the first one. Okay, the top one, the 0. If for I in response, then I can look at the metadata. So if metadata, not in result, in I, and if metadata in I, then I can do, okay, source doc, let's create a variable and source doc, and then I'm going to say okay I, and then source. That's it. Okay, this makes sense. Now let's come out of this for loop, and now let's use JSONable encoder to show that. Okay, so encode that. So what we can do, response underscore data, and in that data I'm going to use JSONable encoder, and in this JSONable encoder I'm going to write json.dumps, and the first thing is json.dump. I'm going to say let's print it like this, result and source document equals source doc. I think there will be one more or something. Okay, looks nice. Let's see if we get any error, guys. I think this logic is right. So this response, so now let's see response, response, and in this response I can pass my response data, and I can just return this response. Okay, now that's it. This looks nice. So what I'm going to do here, I'm going to say okay, if name underscore underscore main underscore underscore, excuse me, okay, I don't know why I removed that. Okay, and I can say uvcon dot run, and I'm going to say okay app colon app, so you can run it in Python or something like that. Okay, app colon app, then I have host, and my host is nothing but localhost, and my port is 8000, and it runs on 8000 port. So port 8000, not 8080, which is for Jupyter notebook, port 8000, and then look reload equals true. So you change your code in the back end, and it will reflect on the front end. We are done with this, guy. Let me quickly explain what I have done in this. We have created this ingest.py, where we have created the vector store within this vector store folder, and now we are writing this app.py, imported all the libraries, initiated a FastAPI app, mounted the static and Jinja 2 templates for templating, giving that local vector store path. Then I have custom prompt templates, simple prompt for context based retrieval, and then I have set that custom prompt using prompt template module in Langchain. Then I am using C transformers to load the model, giving a right model type and model. max new tokens 512. Then I'm using a retrieval QA chain. If you want to develop a chat with code or chat with GitHub or chat with code bases, please, you can also use conversational retrieval chain or conversational, the chain of Langchain. Okay, where you can give memory and chat history, etc. And here we have QA model function, QA bot, where utilizing that embeddings DB LLM and then returning the QA and writing a final result, just to parse the query. Okay, and then we have couple of endpoints. This is the main endpoint, get response. We're just utilizing it. So that's it, guys. And now let's run this application to see if we are getting any error or if it's running fine. So let's open this. Excuse me. So let's open this. So now let's open the terminal here, guys, and we are going to run the this application. So how we're going to run this application is very simple. Python app.py, and it will say application is startup complete or something on 8000, and then we can open that. So let me just come over here and do localhost 8000. Okay, and you see this your Private StackOverflow UI or something, and then you can enter your question here. Okay, now let me have a look what question we can ask. Create a graph. Let me just see if this can create a graph operation instead of definitive operation with the given handle to the, I don't know if referring to an operation in G. Let me copy this and see if it's able to if this is the right question. I don't know. Create a graph operation instance, because this looks even grammatically incorrect, but it's okay. Public final class graph operation extend. Well, let's try it out, guys. So when I click on submit, what it's going to do, it's going to look at the relevant chunks in that vector store and then give it to a large language model, and that will basically present you the answer or the information in a very concise or summarized way or something like that. Okay, so it will take little time, to when you're running it for the first time, it might take a little more time, and it takes around 40 to 45 seconds to retrieve the answers. Okay, let's see what else we can ask here. Implementation then we have export meta llama bin text llama to wait. What we can ask here, and it says it didn't give you the code, but at least it gave you the some information. This is a graph operation instance, which refers to an operation in a given graph. The graph object with this graph operation will be used for all operations of the given graph. This makes it easy to save and restore state when doing computation with the graph. So it didn't give you the code, create a graph, but it did explain you. So let's ask some other question here. So let me see what we can ask quickly. Concate weight function. Okay, and define concate weight function. Okay, or let me ask this, export the llama to weight in that format or something like this. Okay, now if you want to ask this and see what it does this time. Okay, exports the llama 2 weights in llama 2 c.bin format. Okay, and most probably sometimes this model do hallucinates. Okay, most of the open source large language models, and so there are ways that you can control the hallucination rate, and the entire industry is working towards that, guys. Okay, so let me just go to the last file, which is an AOAI text, and let me open this. Run image classification text, which says, let's see, result training argument, fine tuning data. Let me see. Meanwhile that is running, so let it run. Main function, sending telemetry. Okay, this looks nice. Auto config auto model for image classification dot from pre-trained. Okay, let me see if I can just copy this next question, and I can say write a code or something. Okay, so let's say it's still running, and I can see it says it's happening, right? The post request that we have made it to the endpoint, and it's creating a new one with main pooling, and we got something. Let's see what did we get here. We did get, and we got the source document, we got something here, but it's not giving you the right, like the complete code, which makes sense because you have to look at the max tokens and to increase that, and also what kind of machine that you have, to get the complete code out of it. Okay, now let me just ask one more question here, and let's make it little coherent. So write the code for auto model for image classification for pre-trained, for fine tuning and image. Okay, let me that, what was that? Okay, and image classification model. Okay, image classification model. Okay, I'm gonna do that, and let's see, this is the last question that we have asked. So maybe you can play around the maximum tokens, and try to increase it and keep temperature 0. I'll recommend that doing it. Maybe you can also try using Llama 2 with this, and let me know. I'll be very curious to know, because I haven't tried it, to be honest. But you can have a code specific embeddings model with a couple of Langchain chains and templates, and then you use a large language model, for example Llama 2 13B at least, or even you can try it with 7B to see what kind of responses you are getting for this. But this entire code will be given on the GitHub repository. You can take the same backend, and I'll show you. You can also directly use the Swagger UI. I'll show it after this response. So let it load. Okay, and we can ask some other questions. So AOAI, which is Azure OpenAI, they have something here. Chat models would use data, prepare body headers with data. Azure cognitive search. To stream with data. So you can see it takes around 45 to 50 seconds, and sometimes even more, depending on that how many chunks has been that the model is looking at in that vector store, and all that computation. Okay, so let's see, we'll quickly wrap this up now. Okay, AOAI, OpenAI chat response, create another OpenAI data conversation, and you can see it's running here. Unknown tokenizer, unknown token. Okay, maybe we can handle that as well, and let's see if we get the response for it. Otherwise we can also handle that unknown token. Okay, and it did hallucinated. Okay, so it says original code is based on Hugging Face Transformers library and supports a variety of models such as, so auto model, write the code. I said write the code for auto model for image classification dot from pre-trained, for fine tuning and image classification model, but it did hallucinated. Okay, it didn't give you the right response there. Okay, for this, but this is okay. So you can maybe you can try with some other large language model and see if that improve the performance of this application. Okay, but this is what I wanted to do. Okay, and what I was saying is you can also look at, if you just hit docs, and it will take you to the Swagger UI, and you can also use this get response, the post method. You can click on try it out, and here you can pass your query. So if you pass your query here, you will get that response here in that the below section, and you can also use this endpoint in a Postman API client or something like that. Okay, so you can ask your query here and do that as well. So I'll just go on localhost 8000 back to UI, and you can see it over here. So that's all, guys. That's what I wanted to do in this video, but maybe you can extend this further, improve the performance of this application, the entire stack, and let me know if you are able to do something something great with this, to be honest. So the code will be given on my GitHub repository. Let me know if you have any thoughts, comments, or feedbacks on this one. That's all, guys, for this video, and please subscribe to the channel, and please share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.